So this week we are going to start a new series on Wednesdays, Interview with a Scientist. This week we are going to be interviewing Dr. Katie Cooper, who is a geophysicist at WSU, and I think that you'll find it really interesting. Enjoy. Do you want to introduce yourself and tell my students who you are and where you work and what you do?
Sure. I'm Katie Cooper. I'm a geophysicist. I work at Washington State University as a professor. And my job specifically is to do a combination of teaching students and mentoring students, as well as then conducting research.
Okay.
And so I study the Earth and other planets and or really planetary bodies, I should say, to be more specific, and how the interior processes then affect what we see on the surface.
Yeah. Okay, so when did you decide to become a scientist?
Pretty early age. I really have only wanted to be two things in my life. One was a ballerina and the other was a scientist. But I grew up in a really, really tiny area in South Dakota. That's where I was born. And there weren't really dance places there, but there were always things to ponder about. And then I moved to West Texas, probably when I was about 6, where I then I really started getting into wondering, as like I look around where I am, it's like, I wonder how that was formed. And that was in part guided by my parents, who are very inquisitive people as well too. Neither of which are scientists though.
So what kind of schooling did you have?
So I was really helpful to get a lot of opportunities to engage in science from about middle school on, in math and science competitions, as well as computer science competitions, and then computer science in middle school, which was pretty wild. And then in high school, I had a geology class then as well too, which that kind of sparked some interest. And then this is very rare. I went in day one into my undergrad program knowing that I wanted to do geophysics, which is a very specialized field.
Yeah.
And it's in part from a high school teacher saying, hey, you love geology. Clearly this is your passion, but you also really like math.
Okay, so your teacher suggested going into geology because you really liked it. And you also liked math, so.
Yeah, they said do geophysics, which I didn't even know that was a thing. And
Yeah.
so it was really awesome to then know that that was an avenue to be able to combine different parts of science that I really liked in it.
Yeah, that's awesome.
Yeah.
So what do you do for your research?
So I actually do computer simulations of the Earth. So it's kind of like Sim World, but scaled up to the planet. And so what I do is since the Earth evolves very, very, very slowly, it becomes really hard to actually then get something other than today's snapshot of what the Earth looks like. So then you have to rely on physics to help you say, how did it get to today's snapshot? Mm-hmm. And so I say, well, okay, well, if the Earth's interior is kind of behaving like a lava lamp, you have some motion, some materials moving down because they're cold and some materials coming up because they're warm. What are the physics that explain that? And so then I can set that all up in a problem and then ask computers to do it, because that math is not actually, you can't solve that by pencil and paper as much as I like to try. There's a lot of ways that you can make simplifications to solve it by hand, but then to do the full kind of solving those problems, I turn to computers. Mm-hmm. So I do it for Earth primarily, and I look at think about, why do we have continents on the Earth? Why? I mean, that's just kind of a big question that honestly we don't have a great answer for yet.
Yeah.
Why do we have mountains where we do? We kind of are getting there with that. But then I also compare it to other planetary bodies as well. And I have a student who's doing a lot of work on Europa, which is one of the icy moons of Jupiter, and where he's then setting up different models of, because it's really interesting. So it's got an icy shell around it, and he's looking at well, how quickly did that icy shell form, and how much does it change in thickness with time?
That's really cool.
I know. Then I have another student who's studying how when you have volcanic eruptions, you sometimes send out a lot of clasts with it too,
Mhm.
and they can pile up, which is cool and interesting in itself, but it becomes a little bit of a problem. If you imagine if you have things that are still partially molten stacking on top of each other, if they don't cool fast enough, they can slump over and that becomes a big hazard problem. And
Yeah.
so she's modeling the cooling rate of those clasts.
Okay. That's really cool.
Mhm.
Okay. Um, what is the most interesting thing that you have discovered in your research?
Well, this actually, it's interesting because it's something I discovered, but then somebody used my result to show something
Mhm.
else that was really fascinating. I did not expect this. And this
That
only
is
just
cool.
came out this past month that I was made aware of this.
Mhm.
But I did a lot of, this is like my very first paper and like my very first project really that I did, that then showed that there are regions of the continents that act kind of as anchors within the Earth's mantle, and they keep the continents hanging out a little bit lower than what we would expect them to be, of sitting out above the sea level. But because of that, that then has implications for way back in early Earth history of when continents started to rise out of the oceans. And then that connects to the big life explosion of Cambrian explosion,
Okay.
and making the right conditions for trilobites to be, which I did
That's
not
really
expect to be anything of my research ever to connect to trilobites ever, which is super cool.
Yeah, that is awesome. Well, those are the questions I have for you today, Dr. Cooper. And thank you so much for like just being willing to do this for my class, because I think it'll be interesting for them to just see what different scientists all over do. So thank you. I appreciate it.
Absolutely. Keep
So
curious, everybody.